This video is all about algebraic vectors, where we're going to be doing some work with vectors, but we're not going to be specifying what they are in terms of x, y, z components or anything like that. We're just going to be working algebraically. We're just going to do one example, which looks like this. So A, B, C, D is a trapezium. We're told that the vector AB is 2A, the vector AD is B, and we're told that DC is half of AB. So let me mark that information onto my diagram. The vector from A to B is 2A. The vector from A to D is vector B. And I'm told that DC is half of AB. I also know that DC is parallel to AB because it's a trapezium. If it's a trapezium, I know these two lines have to be parallel and therefore in the same direction. So if it's in the same direction as 2A but half as big, it's just A. I'm then told that point P divides BD. So first of all, let me mark on the line BD. Here's BD. And P divides that, which means P is on that line, such that the ratio BP to PD is 2 to 1. So BP is 2, PD is 1. So the distance BP is bigger than PD. So I think P is going to be there somewhere, where the distance BP, B to P, is 2 parts, and the distance P to D is 1 part. So 3 parts in total. BP is 2/3 of the whole vector. PD is 1/3 of the whole BD vector. Okay, right. So I've marked all the information onto my diagram. Part A, find AC. AC should be relatively easy. I can go from A to D plus D to C. So A to D plus D to C, which is B plus A, or in alphabetical order if you prefer. You don't have to, but you might like to. A plus B. So that's part A of this question done. The vector AC is A plus B. Right, part B. Find the vector A to P. So let me mark that onto my diagram. A to P is like this. Now, the way I'm going to work out the vector AP is I'm going to go from A to B and then B to P. A to B plus B to P. Now, the vector AB, I know that easily. That's just 2A. The vector BP from here to here, I'm not quite sure what that is yet. But I do know it's 2/3 of the whole vector BD. So I do know it's 2/3 of whatever BD is. So the question then is, what's the vector BD? So let's just do a bit of rough working out here. BD, what is that? Well, the vector B to D is going to be the same as B to A plus A to D. B to A plus A to D. So the B to A is going to be minus 2A because it's in the opposite direction here. So minus 2A. And the vector AD is B. So that is the vector BD. So therefore BP is 2/3 of that. Now I have managed to work out the vector AP solely in terms of the vector A and the vector B. I just want to simplify this now. So I'm going to expand the bracket and collect up like terms. So I've got the 2A at the front, then I've got 2/3 times -2, so -4/3A, then 2/3 times B is 2/3 B. And if I collect up the like terms now, I've got 2A minus 4/3A. So collecting these together, I get 2/3 A, because 2 minus 4/3 is 2/3, plus 2/3 B. And that's the answer to part B. This is my vector AP. This is my vector AC. Now, part C of the question says, hence, so using what I've just done, I need to explain why it is that APC is a straight line. So why is it that my APC is a straight line? Well, what do we notice about what we've done in part A? I've said that AC is A plus B, and I've said that AP is 2/3 A plus 2/3 B. Now, comparing those two vectors, I hope that you can see that this vector, AP, is 2/3 of this vector. If I just multiply AC by 2/3, I get the vector AP. So I can say that AP is equal to 2/3 AC. Timesing this by 2/3 gives this. Now what that means is, therefore, AP and AC are parallel. They are in the same direction. So I have two vectors here that are parallel. Not only are they parallel, they also share a common point. They share the point A. A was included in both of these vectors. And if we have two lines that are parallel, that go through the same point, they must form a straight line. There's no way possible that it cannot. If I've got two vectors that both go through a point A, and those vectors are parallel in the same direction, then it must be a straight line. There's no way it can't be. It's not like I've got two parallel vectors that don't go through the same point. It's not like I've got two vectors that go through a point that aren't parallel and don't make a straight line. If I've got two parallel vectors that share a common point, they must be a straight line. So, just to finish off part C, I'm going to say hence explain why APC is a straight line. AP and AC are parallel and share point A. Therefore, APC is a straight line. So if you are asked to show that something is a straight line, what you need to do is to pick a point. In this case here, I picked point A, work out the vector AP, work out the vector AC, and show that they're parallel. Alternatively, that's not the only way you could have done this. You could instead have decided, part A and B set this question up to do it this way, but just generally, you could instead have worked out the vector A to P and then worked out the vector P to C. That would still work, as long as they're both parallel, which they will be, and they both go through the point P, then that will again prove that these two, this line APC is a straight line. It doesn't matter what combination you can pick any combination of A, P and C you like, as long as you have a common point and you show that the two vectors involving that common point are both parallel.